In the last video, we ran out of time when we were working on this problem, so let's go ahead and review what we did. We were finding the probability of area, so we have to calculate area, and it says the target has a diameter of 28 centimeters, the inner circle has a diameter of 4 centimeters, and the width of each ring is 4 centimeters. So that means from here to here is 4 centimeters, 4 centimeters, 4 centimeters, and 4 centimeters. Which tells me that, let's see, this radius is only 2, but this one's 4. 4, 4, 4, and 2. So the whole circle has a radius of 14 centimeters. It says the width of each ring is 4 centimeters. A dart hits the target at a random point. What is the probability that it lands in the center? The red region, the red or yellow region, and the blue or yellow region. So what I did here off to the side in the last video is I calculated the total area of the outside circle. So it's this whole circle. I calculated the area to be 196 pi. I calculated just the center circle to be 4 pi because it had a radius of 2. I calculated the red portion of this to be the red circle, the whole red circle minus the whole yellow circle. So the red circle has a radius of 4 plus 4 plus 2 is 8. 4 plus 4 plus 2 is 10. And the yellow circle has a radius of 4 plus 2 is 6. So I subtracted their areas to get 64 pi. Then lastly, I did the blue. Well, I think I did the yellow as well, but the blue, I did the outside of the big circle, which I already calculated to be 196 pi, and I subtracted the area of the red circle, and the red circle had an area of 64 pi. Oh, did I do that right? Oh, the red circle had a radius of 10 pi, so I subtracted 10 pi or 10 squared pi from 196 pi to get 96 pi. And then lastly, the yellow circle. So the yellow circle has a radius of 6, and then I have to subtract the white circle, the center circle, from that. So I did 6 squared times pi minus 2 squared times pi, which was 4. 36 minus 4 is 32 pi. So I calculated the areas of all my shaded regions, and then I went through and I took the shaded region that it's asking for and put it over the total area. So for instance, the center was 4 pi over 196 pi, which reduced to 1/49. The red region was 64 pi over 196 pi, and that reduced to 16 over 49. And then we did the red or the yellow region, so it could land randomly in either one. So the red plus the yellow region was 64 pi plus 32 pi all over the total region. And we're going to do the same for the blue and the yellow region. We're going to add those areas together. So it's going to be 96 pi plus 32 pi, and we're going to put that over the total area, which is 196 pi. So we end up getting, let's see, 128 pi over 196 pi, and I know the pi's will reduce out, and I know 4 goes into each one of them. So that goes in 32 times, and this goes in 49 times. So the probability that it lands in either the blue or the yellow is 32 over 49. All right, so our last problem that I wanted to do, and I'll make this one up on the fly, number 5, is I want to find the probability of a point being chosen within this circle that does not land, okay, so does not land, this is going to be 60 degrees, does not land in the shaded region. So if it does not land in the shaded region, then I'm really talking about this region right here, okay? So this circle has a radius of 3 inches, So we need to calculate the area of the total circle. So let's go ahead and calculate the area of the total circle. The total circle is going to be 3 inches. The area is pi 3 inches squared. So the total circle has an area of 9 pi. Okay, but this arc right here, if this arc is 60 degrees, this arc here must be 300 degrees. So I need to find the sector area of this. Okay, so I'm going to say the sector. And remember, sector area is going to be the degree of the arc over 360 degrees times pi r squared. R in this case is 3. So when we reduce this, our zeros reduce out, and 6 goes into both of those. 5, 6 times 9 pi. And I know the 6 and the 9 reduce. 3 goes into both of them. So I end up with 15 pi over 2. So now what I need to do is I need to put the area of the part, the sector, because we're looking for the probability it lands in the sector. So the probability that it lands in the sector is 15 pi over 2, and we have to divide that by the total area of the circle, which is 9 pi. So how do I get rid of that 2? Well, I'm going to multiply by the number 1, 2 over 2. These 2's will cancel. And so now I have 15 pi over 18 pi, which 3 goes into both of them, and the pi's reduce out. So I have 5/6. That's the probability that it's going to fall in the non-shaded region.